Welcome to this presentation on turfgrass communities. A community is all the species that occur in a habitat. Within the community are evolutionary related communities like the community of turfgrasses, the community of insects, and the community of weeds, to name just a few. When describing communities, terms like biodiversity, stability, and the functionality of the ecosystem are used. We will look at some of these terms and how they might apply to turf grasses. Stability is extremely important in the management of turfgrass systems. With the increasing occurrence of weather extremes, how the turfgrass system remains stable is of increasing importance. A definition of a stable turfgrass system is one that has low variability or deviates little from the normal state despite changing environmental conditions. Stability is comprised of two components, resistance and resiliency. Pictorially, resistance can be shown here. The turf community as represented by the yellow circle. The ability of the yellow circle to resist being pushed from its perch is representative of resistance. Those forces that push on our community are mainly environmental. Resiliency is the speed at which a turf community returns to its normal or undisturbed state. Resiliency is pictorially shown here. The center of the V-shaped line designated the normal state of the community, which has now been displaced due to disturbance. The speed by which the community returns to normal would be quicker for A versus B. Within our community, species diversity is important. Diversity is comprised of species richness, which is the number of species in the community, and species composition, which is the identity of the species present. The functional role of species, their resource use, and adaptability to changing conditions are termed functional traits. Species that have similar functional traits are grouped into functional groups. Stability does not occur alone if there are just a lot of species. There needs to be a diversity of functional groups. If you have numerous species in your community, but they all fit into the same functional group, there is not much diversity. This concept is explored more in the presentation on habitat and niches. Theoretically, we can look at how species that differ in functionality can bring stability to a community. Here we have three communities, one dominated by red species, one dominated by a tan species, and a third that is diverse. If we subject them to a disturbance like a warmer summer than normal, or in the case of the third year, a cooler winter, we can see how the species populations change. In a diverse community at the top, the species fluctuate or fill in when one species is susceptible to the environmental change. In the case of the two communities that lack diversity and are dominated by a single species, these communities are more at risk when conditions change that can result in gaps, in this case of turf grasses, turf loss. An example in turf how a diverse community might work is with the root disease summer patch. Annual bluegrass is especially susceptible to this disease, while creeping bentgrass is resistant or highly tolerant. This picture might represent a normal year. The disease is active as showing the symptom of a yellow ring on this predominantly poa-annua turf, but the severity of the disease is minor. Now, in this photograph, the summer condition here is much hotter, and you can see that the circular yellow rings are more obvious and prevalent, showing how active summer patch is on poa-annua. Note the darker green colored turf inside the ring. This is creeping bentgrass filling in as the poa-annua is dying, as you might expect with the concept of diversity and stability. Now, however, we have a third year that is extremely hot, and now poa-annua death is so rapid and the temperatures detrimental enough to creeping bentgrass growth that gaps or dead areas are forming. In this case, from an ecological point, we do not have enough diversity. And from a management standpoint, we probably don't want diversity from a turfgrass species point of view because of the aesthetic and playable surfaces that we manage for. This is a challenge of cultivated systems, just not turf grasses. Now, oftentimes, other species can colonize these dead or gap areas. In this case, summer patch symptom on Kentucky bluegrass is being colonized by weeds. To reinforce the importance of functional groups, I'm going to use the example of a creeping bentgrass turf composed of two different cultivars. By definition, we are looking at a population, creeping bentgrass, and not a community of diverse grass species. But I think it will show what could happen if you have a number of species that are too similar. In this example, we established two creeping bentgrass cultivars, Pencross, which is tolerant of a disease called dollar spot, and a cultivar Crenshaw, which is highly susceptible to the disease. Once established, we determined that the turf was equal components of the two cultivars using molecular techniques to identify the cultivars. We promoted dollar spot epidemics through our plots and sprayed to control the disease once disease levels reached 25% or 90%, then allowed the turf to recover, then exposed them to repeated epidemics. Our control was no disease, where preventative fungicide applications were made. We found was no shift in the population. This table shows the actual data regarding the frequency of marker genes for the two cultivars. The expected value would represent 50% of the population. Although the cultivars varied in tolerance to dollar spot, since their niches or their functional traits are so similar, little change occurred. Again, this was done with a single species population, but it shows the importance of diversity of functional traits in groups. This concludes this presentation on communities.